Hello and welcome back on this new video on the follow-up on functions that we have started last time. Today we're going to do part one of the graphing of functions. So part one starts with something pretty simple. The first graph that I would like to look at with you is the graph of a line. Yes. So let us see if we can actually recall how to graph a line. Very simple, isn't it? So the general equation of a line, as you probably all remember, equation is, you've guessed it, y equals ax plus b. Right? We actually saw this in the analytic geometry video a couple of videos back. So we know A is the slope and B is the y-intercept. Basically now, I don't want necessarily to play with these concepts. I want to play with the graph of a line. How would you graph something like this? So how to graph, very simple. How to graph. I'm going to say you can graph this using very simply a table of values with two very cleverly selected values. So table of values, where the table of values actually look like this. What I want to use as my points are the two intercepts. I'd like to find what happens to x is equal to 0. What is the y value? And then reverse. Y is equal to 0. And what's the y value? With these two things, I plot them in, join the two points, to give you a line, and we get the graph of a line. Nothing could be simpler. Example 1. Example 1. This is so simple that we're going to give it like just 2 stars. So we have something like graph y equals 3x minus 6. Right? So 3x minus 6 is of the shape of y equals ax plus b. Right? Y equals ax plus b. So you can see here that the slope of this line is 3 and that the y-intercept of this line is minus 6. That is all very good, but not so very useful when it comes to time to graph the line. So let's graph the line. If x is 0, let us find the y. We're replacing x by 0. 3 times 0, that would be 0, wouldn't that? And minus 6, so 0 minus 6, it's the y-intercept. It makes full sense. And if y is equal to 0, then this time I got to go 0 is equal to 3x minus 6. Very easy equation to solve. Bring the 6 over, divided by 3. 6 over 3 is 2. And you have here the x-intercept. Just put those 2 points in the Cartesian plane, and you're done. So label your axes, x and y. Make some gradation here. So 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. 0 minus 6. 0 minus 6 is down here. 0 minus 6. While the other point, 2, 0, is up here. All we got to do is, what color shall we use? Black. I wish I had a ruler. I would do a better job. But I don't have a ruler, so I can't do a better job. So I got this line, and the task at hand is done. We have the graph of a line. Simple enough, you understand? 2 stars, easy stuff. Let us move on to something a little more challenging, namely the parabola. All right. So the second type of functions that we are going to be sketching in this course, always in preview of calculus, are parabolas. So I want to sketch parabolas. All right, so parabolas can actually be given to us in more than one form as opposed to a line. Well, the line also can be given in several forms, but most of the time, 99% of the time, y is equal to ax plus b will do the job. Parabola-wise, that can be given in two main forms that you all have seen in high school, of course. Two main forms. Perhaps you remember this. Y equals ax minus h squared plus k. Does that ring a bell? The famous HK thing that we played with extensively in high school. That's a parabola. You know why? Because of the power 2. If you have an x raised to a power of 2, you're going to get a parabola. The other way that we may be given a parabola is this. Ax squared plus bx plus c. That is the one that's going to make us work a little more. If we are given the parabola in the first form, so if we are given the parabola in that form, in the form of a, we have some information about this that is actually very potent to help us sketch the graph. In other words, if you remember, hk is the vertex of the parabola. So if we are given the a form, then hk is the vertex of the parabola, which is nice because it already gives us a pretty important point on this. Furthermore, what do we know? We also know that if, and you probably remember this as well, a being what's in front of the bracket. So I'm going to put it in quotation marks. If the a here in front of the bracket is positive, then the parabola is oriented in which way? Upwards, right? Then the parabola will look, is oriented upwards like this. That's also referred to as concave up in the language of calculus. If the a is negative, then we know that basically the parabola is concave down. Quick question. What happens if what happens if a is 0? Right? You notice that I didn't put any equal sign here. So let me just finish writing my sentence. Parabola is oriented downwards, so concave down. And quick remark, if a is 0, how is it oriented? Trick question. Because if a is 0, then 0 times the bracket will give me 0, and I'll have 0 plus k, which is k. So y equals k is not a parabola anymore. Y equals k is a horizontal line, right? So that's why I don't include the value a is equal to 0 in here. So basically we can do a quick example of this. So example 2, maybe 2.5 stars. Sketch the graph of, say, y equals 3x minus 1 squared plus 2. You recognize here ax minus h squared plus k. Can you identify hk from here? Can you identify h? Can you identify k? Well, x minus h, x minus 1. This suggests that h is 1. And the plus 2 is my k. The a is 3, yes, which is a positive value. So that means what? If a is positive, the parabola shall be oriented up. This information alone allows us for a rough sketch, not a precise sketch, perhaps not even precise enough, but at least we get an idea of what's happening here, because then the graph is going to look somehow like this. So 1, 1, 2, and here is the vertex 1, 2, HK 1, 2. Because it's oriented upwards, then basically we're going to draw an upwards parabola, comme ça, right? And then if we want a little more precision than this, genre, if we want to know like if it's like narrower, wider, and so on, perhaps we can actually find the intercept when x is equal to 0, right? The y-intercept. That parabola, the way that it's oriented, will not have any x-intercepts, but it actually may have a y-intercept. How do I find the y-intercept? I replace x with 0, 0 minus 1 is minus 1, minus 1 squared is 1, 1 times 3 is 3, 3 plus 2 is 5. So you see here that my parabola, the scale-wise, doesn't make much sense. It should actually be, what, a lot steeper if it's going to catch, like it should more be like this, if it's going to catch the value 5 over there. Even then, scale-wise, I could have done that steeper, so that comes up, where this is still my vertex 1, 2. So that's an example, quick example of what you could do if you are given the parabola in the HK form. If you're not given the parabola in the HK form, then we actually are going to have to work a little harder. How so? How so? How so? How so? Consider example 3. So, parabola in the B form. So, y equals ax squared plus bx plus c. If we're given the parabola in the form ax squared plus bx plus c, I'm going to write this a little larger. Y equals ax squared plus bx plus c. Then there's no h, there's no k, we don't have a summit. But we're going to have to work a little differently. If we have this, then we need to do two things. Step one, find the zeros. Find where the parabola crosses the x-axis. How do I do that? How do I find the zeros? I have a lovely formula that does that for me, and that is x equals minus b plus or minus the root of b squared minus 4ac over 2a. The well-known quadratic formula that you all know very well. We have used it before. So minus b plus or minus the root of b squared minus 4ac. That's an a. That's an a. It doesn't look like an a, but now it does. Over 2a. Once this is done, we need to find the vertex, because nothing in here actually sticks out as the vertex. So step 2, find the vertex. And what's the vertex? Where do I find the vertex? It so happens that if you have the two zeros, the vertex is always exactly halfway between the two vertices. So it's the midpoint of the two vertices. Vertex at the midpoint between the two x-intercepts. What's the formula for the midpoint? Facile. You add them up you divide by 2. So you take the first x-intercept, the second x-intercept, you add them up, you divide by 2, and that gives you basically the x-coordinate of the vertex. As for the y-coordinates, we'll talk about that in 1 second. So, given it this way, we're going to do an example. First you find the zeros, then you find the vertex. You have 2 formulae to do that. So let's take a look at an example. So example numéro 3. Again, 2.5 stars. Sketch the graph of y is equal to x squared plus 2x minus 3. You notice that this time, this is actually given in the form y equals ax squared plus bx plus c. Good. So the a, I can actually know this right away, that the a and the b and the c, you're good at this, right? Because you saw the video on solving equations, and then we solved guys like this, equal to 0. That's exactly what we're doing to find the x-intercepts. So, can you identify the ABC from this? A is the coefficient of x squared, so 1. B is the coefficient of x, so 2. And c is minus 3, the constant, 1, 2, and minus 3. So the first thing that I will do is I'm going to use these guys to actually find my x-intercepts. So step 1. Step 1, the x-intercepts, for which I will use my beloved quadratic formula. Moins b minus b plus or minus the root of b squared minus 4ac over 2 times a. These are my x's, x1 and x2. These are my x's. So what's this? Minus 2 plus or minus over 2. What's in the root, guys? What's in the root? Let's start with, I don't know, the multiplications maybe. Minus 3 times 1 is minus 3. Minus 3 times minus 4, that would be 12. That's a 4. 12 plus 4 is 16. Ah, c'est beau. Root of 16, nice number. It's 4. So this is minus 2 plus or minus 4 over 2. That gives us 2 answers. Yes. Minus 2 plus 4 minus 2 minus 4. So what do we got here? This would be equal to 1, and this would be equal to minus 3. And we have our 2 x-intercepts. Oh, victory, oh, victory, oh, victory. We have x-intercepts. Step 2. Let's take a quick look at the vertex. The vertex is the midpoint between my 2 x-intercepts. So, formula for the midpoint, you add them up, you divide by 2. The vertex is at what? Add these guys up. 1 plus minus 3, divide by 2. So the top is minus 2 divided by 2 is minus 1. And that's my x value. So you want to find where the vertex is. You don't have to work too hard. You have already found the x point for the vertex. To find the y point, what do you think we should do? What should we do to find the y point of the vertex if we have the x? Very easy. This here tells you what y is. Y for this type of graph is always x squared plus 2x minus 3. So let's take minus 1 and put it in there. And we'll have a y. You can't get simpler than that. Minus 1 squared, 1. 2 times minus 1, minus 2. Minus 3. So what do we got? 1 minus 2 minus 3. So that would be minus 4. Wouldn't that be? And that's your vertex. And that is your vertex. You got all you need to do actually an even more precise graph than the one we did using the HK thingy because we have more information. So let us sketch the graph of this guy. Let us sketch the graph of this guy. So the graph of this guy, so graph, which is the purpose of the exercise, is to actually come up with what we're going to come up now. X and Y. We're going to do a little bit of gradation here. So 1, 2, minus 1, minus 2, minus 3. So 1, 2, 3, minus 1, minus 2, minus 3, minus 4 would be here. So let us see. Change colors for this. Let us see. Let us put in our x-intercepts. I got 1 and I got minus 3. Right? Now, just in passing, notice that the coefficient of the x squared is 1. Right? So we know that because it's positive 1, this is going to be an upwards parabola. Well, this is actually confirmed by the location of the vertex, isn't it? Vertex is at minus 1, minus 4. So minus 1, minus 4. Join these 3 points, and then you're going to get the graph of a parabola. Very decent graph, actually. Comes up. Notice that my graph is, again, not very precise because I don't really have a ruler, but it seems to come relatively close to cross the axis at minus 3. The fact is that it should cross the axis at minus 3 because minus 3 is the y-intercept of this parabola. Proof? Replace x by 0. 0 squared, 2 times 0, minus 3. 0 minus 3 is a point. 0 minus 3 should be a point. My graph is a little skewed to the right. It should be a point on the graph. You see that here, because you have more information, you can actually make a graph that is actually more precise than the one you can with the HK. The HK doesn't give you the x-intercepts. It only gives you the vertex. Lovely, lovely, lovely. So that's how we deal with parabolas. We'll practice some more in class, of course. And one last function for today. After the line and the parabola, I would like to take a look at the absolute value. So the absolute value goes a bit like this. So third, in terms of the graph study that we want to do, we had line first, we had parabola, now we have absolute value. Absolute value, the form of the absolute value that you may remember looks like this. Y equals, remember, there's still an A, and then there's the absolute value here, and in there we put something that looks like a parabola, but it isn't, the absolute value of x minus h, and then there's a k outside. Yes? So, a couple of things about this guy, namely it has a vertex. It has a vertex, which is in French is un point sommet. So vertex at HK, the usual. A vertex at HK. It also has an A, and again, the same sort of situation with the absolute value happens as in the parabola, right? If A is greater than 0, then upwards, while if A is less than 0, then we're going to get something that is downwards for the absolute value. So I can't do a D, I'm doing a B all the time. It's not downwards, it's downwards. Yes, Senga. Downwards. Here we go. So here's a little example. I think we're down to example 4. These are not ecstatically difficult. Let's give them a rating of 2.5 stars. So, sketch the graph of, what shall we have here? Maybe y is equal to, let's make it interesting, minus 2, absolute value of x plus 1 plus 3. Absolute value, those vertical bars, valeur absolue, absolute value, yes. So, comparing this, sorry to block the screen like this, comparing this to y equals a, absolute value, x minus h plus k. What do I conclude in terms of my hk? All right, x plus 1 compares to a x minus h. X plus 1 compares to x minus h, right? If you put them equal like this, the x's will go. You'll end up with 1 is equal to minus h, which is the same as h is equal to minus 1. As for the k, it's just right there. So minus 1, 3 is the vertex. So vertex at minus 1 and 3. Yes? Now, if you remember the general shape of the absolute value, anybody remembers like what it looks like in terms of a letter in the alphabet? What does it look like? If it's upwards, the absolute value is going to look like a V oriented upwards. And if it's downwards, it's going to look like downwards like this, right? In other words, it's a V. So the shape being a V like this, all we got to know is it a V upwards? Is it a V downwards? Because all we have is the vertex. That's all we need. So because the A here, the A equals what? What's the value of A if I compare it in here? Minus 2 is in front of the absolute value. That's my A. That's negative, less than 0. That means that I'm going to get a downward shape. So downwards. Downwards. So what's the graph? What is the graph of this guy? X-axis, y-axis, couple of points. Here's minus 1, here's 3. I'm going to put the 3 over here. And I'm going to put in my vertex, minus 1 and 3. Right here. Right here, right here. So, since I am oriented downwards because my A is negative, we are actually going to go like this. And then something like that. Again, I could make this more precise if I want to. Maybe I want to. If they ask you for like a very precise graph, give them something more. Genre, give them maybe the x-intercept or the y-intercept maybe. Genre. What would be the y-intercept of something like this? Nothing is easier to compute than a y-intercept because all we got to do is replace x with 0. So if x is 0, I'm going to find the y-intercept easily. If x is 0, 0 plus 1 is 1, absolute value of 1 is 1. 1 times minus 2 is minus 2, minus 2 plus 3 is 1. So 0, 1, see our graph here, this one time is relatively precise. Not that much really, because it seems like the x-intercepts here have not quite yet been established. But for the sake of the argument and because we've achieved our half an hour in the video, I am going to leave it like this and call it a graph. So usually when we actually need this for calculus, a shape like this is close enough to do what we have to do. Good, so we've seen the line, the parabola, and the absolute value. We'll see a couple more in the next video. And that's it for today. I wish you well and see you soon. Ciao, ciao.